Good morning. It's my pleasure to welcome you to this presentation that Sebastián Víquez will make today. He's a quality assurance leader at Isnus Software for a few years already, and he's one of the most passionate persons I know about testing and quality assurance, always seeking new knowledge, leading people into learning about testing and quality and also adopting agile practices and put them to work. So, welcome, Sebastián. Thanks very much for sharing your knowledge. Sebastián has been studying for a number of years, always seeking to learn more and apply that knowledge into his professional work at Ismus Software and other companies. And he's been working with artificial intelligence tools in order to improve his team's productivity in what they call visual testing. So now it's your turn, Sebastián. Welcome. We expect some people from the Hispanic speaking
Thank you for such a warm welcome,
America
Ignacio.
to share.
I, I think there's a delay on the video. I was saying thank you for such a warm welcome. And thank you, Senfotech, for the opportunity. Um, so let's go ahead and start the presentation. Just a moment. Can you see my screen?
Yes.
Okay, so this presentation, as Ignacio mentioned, is based or is going to be based on visual testing and artificial intelligence. I work as a QA lead, automation specialist, and speaker. Some of my certifications related to the subject. Um, it is important to mention that the scope of this presentation is meant for QA professionals that want to learn about visual testing and AI. The objective here is build foundations and start our journey towards visual testing and artificial intelligence. This is not an exhaustive artificial intelligence course. With that being said, our resources, the 2009 State of Automated Visual Testing Review by Applitools, also the impact of visual AI on test automation report, and the Modern Cross-Browser Testing through Visual AI report by Applitools as well. We're also getting feedback from browser stacks, Percy documentation and research, and the Disrupting the Economics and Testing through AI, which is by Enterprise Management Associates. Okay, so the visual aspect of a website or an app is the first thing that end users encounter while using the application. Now, for business to deliver the best possible user experience, especially in a visual-driven culture, like aesthetical and websites, it's necessary for them to be as detailed as possible. Now, given the diversity of devices, platforms, and browsers available on the internet, teams are bound to face a specific visual bugs. Now, what are visual bugs? Let's begin with that fundamental question. Visual bugs are issues associated with the user interface, also known as graphic user interface or GUI, of a web or mobile application. Although these bugs do not have any functionality or functional impact, they can ruin a particular website or the user experience. A few examples of visual bugs will be misaligned text bottom or misalignment based on the viewport, overlapping images, partially visible elements, like the ones that we see on the screen, responsive layout issues, not showing the font based on the color. I mean, there are a lot of visual issues that we can encounter nowadays. One of the, or in some cases, the visual bugs obstruct end users from accessing the key functionalities of an application. In such a case, that bug needs to be reported as a functional bug. As mentioned earlier, any visual bug can ruin the user experience. Consequently, this can negatively impact the way end users perceive a particular brand online. You can see an example here. What I'm showing is an example from an actual airline. This is the application, and this is what the user encountered when he was trying to book a flight. So you can just imagine the impact that this will have for the end user. Now, what is visual testing? Visual testing is the automated process of comparing visual output of an application or website against a baseline image. In its most basic form, visual testing, sometimes also referred as visual AI testing or visual diff testing, snapshot testing, compares differences in an image by looking at the pixel variations. In other words, testing a web or a native mobile application by looking at the fully rendered pages and screen as they appear before customers. This was historically done manually or by using error-prone pixel matching and DOM-based tools, which is what we're going to review later on. Now, the modern approach have incorporated artificial intelligence, also known as visual AI, to view as a human eye would and avoid false positive, which is our main objective, to avoid those false positive. Now, there are types of visual testings or visual testing. An interesting thing about visual testing is there are different ways to handle this. One approach, as you can see on the screen, is by using pixel by pixel comparisons, in which the testing framework will flag literally any difference it seems between two images. Such comparison provide an entry level into visual testing. It tends to be fluky and can lead to a lot of false positive, which is time consuming. And the reason why is because it basically compare every little single pixel for every snapshot that you take. So it basically, I mean, if there is just one single pixel missing or it was rendered differently, then it will give us a false positive. So that is not the way you approach to visual testing, or at least the old approach that we were using uh, years ago when we approached to visual testing. Now, as mentioned, traditional pixel-based visual testing cannot handle dynamic content because of the pixel differences, shifting elements, different screen size, dynamic content. I mean, it's all around. Nowadays, you will find dynamic content on every single app. So this traditional approach is no longer, um, I wouldn't say supported, but I will say it's already obsolete. Now, another approach to visual test is by using DOM comparisons. This is basically to capture the DOM of the page and compare it with the DOM capture of a previous version of the page, as you can see on the example. Now, DOM snapshots do not equally visually identical browser outputs. The DOM is the DOM, not what the user sees. Your browser renders the page from the HTML, CSS, and JavaScript, which comprises the DOM. Identical DOM structures can have visual outputs, and different DOM outputs can render identically. And this will be explained shortly. I'm sorry, something that I forgot to mention is the differences that the DOM will miss, or the DOM comparisons will miss. It will miss iframe changes, it will miss broken embedded content, it will miss cross-browser issues, it will miss dynamic content behavior, and one of the main factors that it'll miss is it will change and yet render identically, and the DOM comparator flag or will flag a false positive, which is very it will cost more to detect at the time when running the test. As you can see, what I highlighted in blue are dynamic content, or is dynamic content, which is basically ads, and those ads will change each and every time we run the test. Besides, or more than just ads, what could change as well are the font, the size, the color. So those kind of things must be taken into consideration as well. In short, DOM diff ensures that the page structure remains the same from the page snapshot. Now, DOM comparisons on their own are insufficient for ensuring visual integrity. A combination of pixel and DOM diff can mitigate some of the limitations. Lastly, we have the visual AI approach. Before going into the visual AI approach, I want to mention some automated visual regression testing tools. Now, there are a lot of visual regression testing tools. You have Coviton, you have Apply Tools, you have Percy from BrowserStack, Lambda Test, cross-browser testing from SmartBear, Chromatic, Screen by Sauce Lab, by Sauce Visuals. The approach, I mean, it depends. If you're looking for a tool that can be used specifically for mobile testing teams, then Coviton will be your option. If you're looking to handle desktop and web applications, Percy from BrowserStack or Apply Tools might be the right choice. So it depends on the framework, it depends on your needs, it depends on your budget. So those things must be taken into consideration when selecting a tool for visual testing. Now, is there any free open source visual validation tool? There are a lot as well. You have HShot, you have FB Snapshot, you have Gemini, you have Needle, you have Phantom, you have PixDiff, you have RSpec from Page Regression, you have Selenium, Visual Diff, Spectre, Visualception, Bisgrex, and the list goes on. This is just the ones that I wanted to mention, or at least the ones that I know or have knowledge. But the list goes on. So there are a lot of free open source visual validation tools that can be used. Now, what happens with these tools? As mentioned, DOM-based tools don't make visual evaluations. DOM-based tools identify DOM differences. These differences may or may not have visual implications. DOM-based tools result in false positive differences that don't matter but require human judgment to render a decision that the difference is unimportant. They also result in false negative, which means they will pass something that is visually different. This is a key concept to understand. In the other approach, pix-based tools don't make evaluations either. Pix-based tools highlight pixel differences, as mentioned. They are liable to report false positive due to pixel differences on a page. In some cases, all the pixels shift due to an enlarged element at the beginning. Pixel technology cannot distinguish the elements as elements. This means pixel technology cannot see the forest from the trees. Now let's go ahead and take a look to the AI approach. We're going to start with the definition of artificial intelligence. Wikipedia notes artificial intelligence. That artificial intelligence is often described as machines or computers that mimic cognitive functions that humans associate with the human mind, such as learning and problem solving. Excuse me. Algorithms that have been around for a long time, like the optical character recognition, by definition are AI. While this may be true, modern technology trends to rise the bar on what is considered artificial intelligence. Today, the usage of machine learning and deep learning models is what is typically accepted as artificial intelligence. So now that we mentioned deep learning, I also wanted to mention that visual AI is made up of a network of hundreds of algorithms implemented using different tools and approaches ranging from hand-coded rule-based algorithms to deep learning complex. Algorithms automatically clean up and tag data, which is then used for training the machine learning and deep learning models. And this is basically how our tool or visual AI validations work, based on these models, based on this approach, based on these algorithms. So let's go to the key question. What is visual AI? Visual AI is a form of computer vision invented by Apply Tools in 2013 to help quality engineers test and monitor today's modern apps at the speed of continuous integration, continuous development. Visual AI inspects every page, screen, viewport, browser combination for both web and native mobile apps and reports back any regression it sees. Visual AI looks at applications that the same way the human eye and brain will do. but without tiring or making mistakes, given a 99% level of accuracy. Now, in traditional testing, what you'll do is rely on DOM locators, like the ones that we see on the screen. Field labels, text such as messages, validate different aspects of the user interface elements. But the DOM locators, labels, and messages can change at any point, leading to a lot of unnecessary tests. Secondly, and equally important, since people can reasonably test hundreds of UI elements on every page of a given app, they are forced to test subset, again, leading to a lot of production bugs due to the lack of coverage. With Visual AI, you can take a screenshot and validate the entire page. This limits the tester reliance on DOM locators, which is the old approach or the most common approach. Additionally, you can test all elements rather than having to pick and choose. In the end, Visual AI, you'll write less code, get more coverage, and have far more reliable tests. Why use Visual AI? First, functional testing requires visual validation. Otherwise, it's myopic to changes you expect and blind to changes that you didn't expect. In other words, functional tests only check behavioral outcomes, not UI changes. And this is a key concept to understand. It is difficult to assert visual correctness with code. Second, the reason why you likely don't do visual validations is that the tools you have today are not working due to many false positives. And this is the old approach. When we started to use pixel-based tools or DOM-based tools, we were getting a lot of false positives. And finally, Visual AI overcomes the problems of pixel and DOM for visual validations and has enough accuracy to be used in production for functional testing. Basically, it captures the screen, breaks it into visual elements, compare the visual elements with older screen image broken into visual elements as well, and then identify visual differences. It also handles dynamic content, and that is one of the improvements I'll see or I will repeatedly mention on this presentation: dynamic content. The importance of handling this dynamic content nowadays is one of the key factors of success of Visual AI. Now, Visual AI has the DOM to guide it, as the DOM represents what should be on the page and where. The Visual AI uses the DOM to identify the layout, as we can see on the screen, location and spacing within the layout. Visual AI identify elements algorithmically for any checkpoint image, compare against a baseline. On the left, we have the baseline, and on the right, we have the checkout, which is what we are comparing. And basically, we'll identify differences in the layout as well as differences within the visual elements contained within the layout. Each given page renders as a visual image comprised of visual elements. Visual AI treats elements as they appear: text, not a collection of pixels; geometric elements like rectangular circles, not a collection of pixels; and pictures as images and not a collection of pixels. Now, we're going to move to one of the reports from Applitools or the studies from Applitools. They are pioneers on visual AI. On the impact of visual artificial intelligence report, they did this study with several engineers, about 300 engineers, and what they did was start comparing how much it took for an engineer to create, let's say, a suite of tests from scratch versus how much it took to the same engineer to just write the same test using the visual artificial intelligence approach with their driver or with the application they're currently using. So on this specific scenario, we have 5.8 times faster on test creation. Now that can vary depending on the framework that you are using, and it also will vary depending on the test that you are writing. For instance, if in this, I'm going to show this later on, if you're writing a test where you're checking if all elements are displayed within a certain website, then you will have to tag each and one of the elements of the website. That will be time consuming. It will take a lot of time, and that can be easily done by just using the AI approach, and it will probably take, I don't know, maybe 1 or 2 minutes. So it depends on what exactly you are going to create or test. Now, before going into the other part, what does this mean to the tester? Testers are able to expand test coverage while simultaneously testing faster than before, what I just mentioned. What it means to the team, more coverage and faster testing. By including visual AI in the approach, quality engineers obtain some amount of coverage or more coverage. And this is another key factor, the amount of coverage that you will obtain while using visual AI. Now, this report, the impact of visual AI on or expands, I'm sorry, to the part of test automation, which gathers about 288 quality engineers automating tests with different frameworks or tools like Cypress, Selenium, WebDriver IO. And one of the key findings was the automated test time, the code test efficiency, the test stability, the test coverage. And this is what I would like to mention and show you. Now, they found more test code efficient, 5.9 times more test code efficient when writing or automating tests. What that means, or what means to the tester can either achieve the same amount of test coverage using far less test code, another key factor of using AI, or dramatically expand test coverage using the same amount of test code as they do today. What it means to the team, well, test code is slow to write in some cases and slow to run. With less code or less of it, teams can either expand coverage or run tests faster on some combination or of both. What do they mean by test code efficiency? In addition to the standard metrics of testers' efficiency, the study yielded a new measure called test code efficiency. Similar to the concept of code efficiency that the software developers look at their work, test code efficiency measures both the number of lines of test code a quality engineer can write per hour and the efficiency each line of code provides. Visual AI, which captures images of an entire page with a single open-ended line of code, which is eyes that window, is more efficient because it is both easy to write and each individual line of code provides more coverage than code-based approaches that relied on close-ended assertions. So what we can see here is basically the approach that they were using from a code base versus a visual AI approach and the impact. So we have on the left the submitters, then the code base, the visual approach, and on the right the impact. So we have a total of 351 lines of code versus 180 lines of code, giving us 49% less raw test code. It's a lot of code that you will save or you will avoid. We have 15 lines of code per hour versus 150 lines that you can create, which is 3 times more productive. We have 351 lines of code for the adjusted lines of test code versus 60 lines of test code, which is 5.9 more code efficient. So you can just imagine the difference when it comes to efficiency, when it comes to being more productive. Something else that I wanted to mention is the impact of modern cross-browser testing. There are several frameworks that allow nowadays cross-browser testing. You can also create a lab for cross-browser testing, but that will take or consume a lot of time, resources, and money. So nowadays, what it's used is cloud-based cross-browser testing, which is the approach. Now, using their cloud-based AI approach, they found 18.2 faster to complete the full test cycle. I'm going to explain it later on. What this means to the engineers. Engineers now have ultra-fast grid and visual AI technology capable of comprehensively testing large modern apps across dozens of environments. And what it means to the team, well, the QA bottleneck holding back release velocity is eliminated, enabling CI/CD. Application quality simultaneously improved dramatically. And I'm going to show you guys why. They also found 81 times more test code and screenshot efficient based on the lines of code. Basically, what it means is that it will analyze or give us a 99 accurate visual, which will reduce false positive. And what it means to the team, well, testing speeds and coverage increased with almost zero added maintenance. And this is another key factor, the maintenance, the time that we will take to give some maintenance to our code. Now, this is the part where I wanted to show you guys the approach when it comes to cross-browser testing. On the right, we have some of the frameworks that are currently being used for cross-browser testing. We have Browser Stack, we have cross-browser testing, we have Sauce Lab. This is the traditional approach where you will need to basically install, write, run, analyze, report, maintain, and approximately for that cycle to complete, if everything goes well, I mean, if you don't face any issues, that will take about 29 hours for test cycle. On the left, we have the Apple tools using the AI approach, which is basically the same cycle: install, write, run, analyze, report, maintain. But on this approach, we will take about 1.6 hours approximately to complete a full test cycle. And the reason why is not just the amount of lines of code that we will save, but also the installations and configurations. And I'm talking about dependencies. I'm talking about building or connecting the framework. We will save a lot of time using this approach. We also have a 91% reduction in locator instability versus traditional approaches. What it means to the engineer? Well, reducing reliance on locator means tests break less often and throw far fewer false positives. This allows engineers to expand coverage and to spend more time managing quality. What it means to the team: teams with stable test code can test more and test faster with some combination, or sorry, some combination of both, depending on their needs and goals. Basically, when you relied on locators, I mean, you can use X amount of locators. You can use CSS, the ID, CSS, XPath. I mean, it won't matter if the locator that you're using at some point, that locator, with the exception of the ID, in some cases it might change, but that will be the exception, uh, could break. So using this approach, we will save that maintenance time on changing those locators. This will be the approach when it comes to AI. I'm going to explain this later on our demo, where we have the base, the checkpoint, and the result. Visual AI is the future of testing. Apps, website, and smart devices will continue to proliferate in addition to the increasing number of screen size and page variations that customers demand. Soon, any attempt to manage the visual and functional quality of an app or website with the necessary quality assurance and test coverage is going to be impossible unless you have visual AI technology. Remember, and this is very important, visual AI and test automation are only tools and not the end game. The end game is being customer obsessed and giving customers the highest quality digital experiences as quickly and efficiently as possible. So we're gonna do a demo on this framework that I want to or this tool that I want to present, which is Amplitude, and I'm going to show you or compare it to other frameworks if we have some time, so you can make your own conclusions. Um, the reason I like this framework is because they are pioneers on or when it comes to visual AI. So let me see if I'm able to. Okay, let me just a moment. So this is one of the projects that I'm working on. It is basically a Java Selenium project. I'm using IntelliJ IDE, and I wanted to show you guys how to configure the driver. It's basically just calling the driver and then set it up with an API key that you will find on their website based on your account. You can set different options that I'm going to show you how it works. And before I run this, I just want to show you the difference between running a, let's say, it could be any test on the old approach. Whenever you were about to check on if an element was displayed or not, let's say this one right here, and this is just one single test, it's very small, where we're just checking elements on a menu. So take a look at the amount of elements that I'm checking if are displayed or not. I mean, we're talking about a lot of elements, and this is just one single page from one single menu. And this was the old approach. And it goes down because there are a lot of elements. And I'm checking on or validating or asserting then all elements are on that page, exist on that page. Now, let's go ahead and take a look on the other approach. This is a test. It goes to the menu. It just opens the driver, the Apple Tools driver. It checks the window, and then it closes. And that's about it. 4 lines of code. That's it. So you can see the difference. Now, let's go ahead and run. Let's go ahead and run this. Okay. Let me just a moment. Let me check on something. Okay, I apologize. Let me just a moment. Okay, so basically the way it works is as usual. It will launch the browser, it will start or go to the URL that I'm evaluating or the page that I'm evaluating. And then it will open the driver for App Tools, and it will start the evaluation. Okay, it goes to the menu, It will adjust the viewport based on the settings that I have set for this particular page, and it will take not only the snapshot, but it will also start scanning the entire page, and it will separate each and every element of the page to create a model of what is render or the CSS. So it's not only taking a snapshot, it's analyzing the entire page for DOM. It finished, so let's go ahead and take a look. So before I show you the test, let's go ahead and take a look at the test, and then I will show you the other one. Okay, so this has been marked as new, as you can see right here. And the reason why it was marked as new is because we don't have a baseline, and that is exactly what I wanted to show you guys. The first scan or the first review that you do with this will create a baseline that you can accept or not. So it already passed. We have our baseline right here. Okay. So we're just going to close this. Okay. And we're going to run it again. The same test. So you can see when we compare both the baseline and the checkpoint, which is what we are comparing. So it'll be the same process. You will open the browser. After opening the browser, it will go to call the driver. It will scan the page. It will check for any difference, and then it will stop the driver. It is about to finish. Okay, it's done. Okay, so we have, give me a moment. Okay, now it says that it passed. So let's go ahead and take a look. It passed because it found no differences, which is the happy path, right? We're just analyzing based on a algorithm, the strict mode algorithm, which will basically check not only on the layout, but also the content of the page. It will check on each and every element as mentioned separately, and will give us feedback if some differences were found. Now, that will be the default matching level or algorithm that we are going to use, or that the framework use. But what happens if we change the match level? If we go to, let's say, exact, do we have some differences? There's a couple right here. The image is still trying to render because it was zoomed in. As you can see, let me highlight the differences. You see those dots are highlighting some differences. Let's see if I found another one. Those are pixel differences. And this is the reason why pixel diff is not useful, because it will fail the test because of the way that the page was rendered when the scan, or when we review the content based on pixel diff. And this is just for, or to show you an example of why pixel diff is not useful, or at this point is obsolete, because it will give us, or each time the page renders, at some point, it won't matter if you're using the same browser, it will give you some differences. And some of them are being displayed right here, mostly on images. Now, the other matching levels, strict as I mentioned, it will check on content, it will check on layout. Content will just check on the content of the page. If everything was saved or taken based on the baseline that we took before. So that will be a more useful approach or algorithm to use when it comes to comparisons. You can see there are no differences because we're not doing a pixel by pixel or using the pixel by pixel approach. Let me go ahead and just move this right here. And we're gonna fail the test. And the reason why we're gonna fail the test is for you to take a look at some of the tools that I want to show you when it comes to this framework. How we can fail this test? Well, we can fail this test by using, let's say, instead of taking the full page screenshot, we're gonna just take the viewport part of it. Now, programmatically, you can also select the type of match level or algorithm that you'll use. On this case, I can use the match level dot layout or the match level dot exact or any other of the match levels or algorithms that I show you. The reason I'm using the default is for you to see the other difference on the dashboard. So let's go ahead and run the same test. We're going to go to our test once again. I believe this was the test. And as mentioned, what this will do is it's just going to take a snapshot of the viewport, whatever you can see on the screen, and it will save it. You can do the same thing with, let's say, elements. You can take, let's say that you don't want to take the entire page in just one single menu. Then you can select a menu for in order to be scanned, instead of taking the time to do a full DOM review, which takes a few more seconds. But at the end of the day, if you want to save a couple of seconds, you can also do that. So let's wait for it. Okay, it's done. Let's go to our test results. And it says unresolved. So let's go ahead and check why. Whenever you see unresolved, it's because some differences were listed. This is our baseline, right? And this is what we just took, our checkpoint. Why is it showing like that? Because I programmatically change to just review what it was on the viewport of the system that I'm currently using. So this is the viewport, whatever the user can see, and this is the entire page. That is the I'm sorry, let me just exit out. Let me go back. That is how you basically can just select regions if you would like to just evaluate one single region instead of the entire page. And that is one of the characteristics of this dashboard that I like the most. Now, let's go ahead and check Well, as you can see, it will mark all these differences because it is all missing. Let's check on the root cause analysis and see if we have some information there. What is the root cause or cause analysis? It is data from each and every review that you make. And this is where AI comes into play, because it will give you not only the differences, it will give you a list of elements or a review of what failed or what was missing based on the checkpoint that you did. So at this level, you're not only changing the algorithm or the way that your um, tool is going to review the screenshot. At this level, what you're checking is all possibilities, or not only possibilities, but also the differences in on this report. You can actually see what was missing for each and every element. It's because I'm clicking right here on the element, and it gives me the review for that particular element. If you zoom in, then you will have some other review. But what I wanted to show you is the level of accuracy that this dashboard has when it comes to identifying what went wrong. So if it failed, if you found some differences, you can just simply go ahead and say, hey, no, this failed. I don't want this. I want to mark my test as failed, and it will save. Let's just wait for it to finish. Okay, didn't load. So I marked the test as failed because it gave me some results that were for sure that failed. The most of it of the page just was missing, so I just marked the test as failed. There are some other things when it comes to artificial intelligence that you can use within this framework. You cannot do on other frameworks, because other frameworks will take snapshots for sure and might detect some differences for you. But when it comes to, let's say, let me give you another example. um, for instance, right here, when it comes to use one algorithm on top of another one, which is very useful, it comes into play the matching level. So let's say that I'm using the exact match level. Okay. So you see the difference between this image and this image. There's a rendering difference based on pixel diff. So what happens if I want to say, hey, no, I'm using the exact algorithm, but I want for that part to be taken into consideration, or add another algorithm or matching level on top of that. Let's say that I want to just use a content region for this. So I just mark right here, and this will be used as content, that particular section. So it doesn't fail once again when I run it. And I can apply the same scope for any other tests related with those same changes. So it will spread out any other change to the entire set of or suite of tests running the same type of test. So this is one of the key characteristics when it comes to using AI, being able to add one algorithm on top of the other one and being able to spread that setup for any other image or review or test that I'm going to do in the future. Now, if we compare this to, let's say, Percy from Browser Stack, which is a great tool as well. I mean, using Percy, Percy is great for CI/CD. You can detect and be very quickly when it comes to reviewing changes on CI/CD projects, like the ones that you can see right here between this snapshot and this other snapshot. It will detect the difference, the color change, or between this one and this one right here. It will detect that the elements change, the color of the elements. But at the end of the day, you won't be able to use, let's say, one matching level on top of the other one. You will be able to change some settings, like the density of the differences that you would like to use, but you won't be able to use one matching level or algorithm on top of the other one. Let's say that let me see if I'm able to. Well, I don't have an example right here, but that is basically the difference in between these tools. Because Percy from Browser Stack is very useful. I mean, I've used it on some occasions, and it detects a lot of the amount of time it takes to detect is 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 a fewer. I mean, the difference are seconds, but it is a good tool when it comes to reviewing very fast on your CI/CD project. But that will be the main difference between using this and using the Tools dashboard. Um, and I think that will be it. Those were the tools or the demo that I wanted to show you guys.
Sebastian, I had several questions that I wrote about along the way. It's really impressive, and it's very nice to see that artificial intelligence techniques have been applied to help in increasing the productivity of testers and developers. I will share with you a vision paper that Herbert Simon, who was a Turing Prize awardee and also a Nobel Prize in economics, he was one of the pioneers of artificial intelligence, and he wrote a paper in 1986, I think, uh, foreseeing the possible uses of artificial intelligence for software engineering. So it's very nice to see that these things, like the things you have shared with us today, are real today, and with such impressive uh, productivity results.
Yeah, it is. It is quite impressive. And one of the things that I like the most is how easy it is to integrate this to our frameworks. I mean, they have. It won't matter if you're using Tools or Percy. You have an SDK. You have a guide on how to implement that to your framework, and I mean, it will guide you step by step. You just need to, as I mentioned, set up the API. Well, first create an account, set up the API, uh, set the driver, and after that it will be your own setup. You can just play with the settings. You can do validations on your desktop, do validations on mobile screens or viewports. You can do whatever you like based on your let's say requirements. If the project it's mobile based, then you will adjust those settings for your mobile devices. You can simulate Android devices, iPhones, iPads, whatever viewport you're using, you can just set it up from there.
Okay. So it is not only for web browsers, but also for native mobile application development. Okay.
Correct. Correct.
In what's locator instability? You put that in one of your slides.
Yeah, locator instability. I'm referring to the fact that when it comes to automating things, let's say elements within a page, most of the times from time to time, the element locator will change. So the element locator, the XPath of a certain locator won't be the same from let's say from the time you took it and after the release, or before the release and after the release, that locator can change. So that will create a failed test or failure because of the locator, not necessarily because there was an issue or there wasn't an error. So when I'm referring to locator instability on the fact that you need to give maintenance to locators that are constantly changing. And I'm not
Okay.
on. Go ahead. Sorry.
No, go.
And I'm not only referring to dynamic elements. I'm referring
Okay.
to static elements as well. Eventually, those will change. So that is what I meant by that.
Excellent. And it surprised me that how complete this tool is, and in providing explanation of the deviations on the observed stuff versus the baseline. Um, so what's the price tag of this kind of tool? Is it based on you pay a license, or it depends on the number
Yeah,
of times you
yeah.
use
That
it?
Yes, of course. The I mean, you'll have to have. This is for enterprise business, so you will have to have some budget in order to get a license, and especially to be able to run cross-browser testing, which is the main characteristics, or which is something that companies would like to gain, right? To gain cross-browser testing and to save some time. It will go for almost about 12, maybe 12,000 approximately a year. Uh, but the good thing is that you can also use the free version of the framework, and you can take about 300 different or do 300 different reviews or tests with them using a same API per month. So let's say that you have a website with two sections. Let's say you have or you have two websites. You have the marketplace, and you also have a another website showing something else. So you can use one API for the marketplace, and you can use one API for the other page, and you can take 600 screenshots or snapshots with them for free without paying. So it's a lot of testing that you can do with the free version as well.
And
And
also for learning.
exactly, mo-
Yes.
most of the features are included in the free version, which is one of the things that I like the most. Most of the providers block a lot of options because it's the free version, and which is not the case right here. Yeah.
Okay. I think I'm very sorry, but we are running short of time. Thank you again, Sebastián, for sharing with us. And I would recommend to people who didn't come in time to watch on YouTube. Fortunately, this gets recorded, and people can look at it at their own pace and as many times as they want. Thank you very
Thank
much.
you. Thank you
And
for the.
very best wishes for you and your family on this Christmas time.
Thank you. Same to you.
Bye
Bye.
bye. Thank you.